Hello everyone. Hello. Today I'm going to explain about the water potability classification. So, what is potability? So, potability is nothing but which indicates that if water is safe for human consumption. So, how much percentage we have to take for the humans to sustain with the water. So coming to the introduction, here the water potability data set is downloaded from the Kaggle website. So I have taken the data sets from the Kaggle website. So drinking water is very important for health and basic human rights. So without water, no man can live. That like all of us know that 73% of the body is covered with the water. So without the water, it's very hard to live. So uh, here the datasets which I took consists of 3276 rows and 10 columns. So these are the datasets I took, and there are 9 columns which are the continuous variables, and target column has two classes. One is 0, means that is not portable. Another one is 1, means portable. So 0 indicates that it's not portable and 1 is portable. Coming to the data analysis, we have to data analysis means like we have to import the pandas from data reading and manipulations. Data analysis includes visualization and understanding each variable in the data set. So there it in this the data is analyzed and visualized. So we have to check the each and every variable in the data set. So here the loading the water quantity data. So here we're gonna check the water quality data. So what is the quality we're gonna take? So here we're gonna import the pandas, and we're gonna read the file, read CSV. And coming to the data visualization, to have an idea about the data set, we use head function to print the 5 rows of data set from the beginning. So here the head function is used to print the rows of the data set, so it would be easy to understand. So as we see that the data set dot head, and here are the 4 values we're gonna take. So here we're gonna see the separate columns, that is pH, the hardness of water solids, chloramines, sulfate, conductivity, organic carbon, triamomethanes, turbidity, and potability. So coming to the numerical analysis, data frame consists of all predicator variables are continuous. We can analyze using the describe function. So here we're going to use the describe function to analyze the numerical analysis. So as we can see that the statistical analysis dataset dot describe. So here the variables are being separated from the count, mean, the standard, minimum, 25%, 50%, 75%, and the max. So here we can see the values from the minimum of the range to the maximum of the range, and with the percentage of 25, 50, and 75. Excuse me. So here you can see the pH, hardness, solids, and each of the value over here. So the count varies. We're gonna do here the mean, the standard, and minimum. So each we want to get the different values for the numerical analysis, and finding the missing values. So it is important that finding the missing values are crucial in the data set. Without filling the missing values, it can be cause the model performance. Uh, Without finding that, there may be we cannot get the correct values in the range. So here we have to uh, checking the null values. So first thing we have to do is check the null values. So here print, as you can see here, the total print null values are data set is null dot sum dot sum. So as in the code, we gonna get that the total null values are 1434, and as we find the missing values, we gonna get the null values as 1343, and we have to replace these values, replacing the missing values. So data set has, as we say, as we seen that the data set got 1434 missing values. So we can fill this with randomized number, or filling with mean or median. I am replacing 0 with missed values, so it would be easy for us as replacing 0 with the missed values. So we're gonna get all the values right. So by replacing the 0, we're gonna get it. So filling null values with 0, data set is equals to data set dot fill 0. Again, coming to the target distribution, so here we're going to discuss like the how much percentage we are going to having the non-portable and portable percentages. So in my project has been done that 60% of the data having non-portable and 40% of portable. So it's going to define by dataset.portability.value counts and dataset multiplied by 100. So as we can see that 0, it gonna get the non-portable as 60% and portable 1 as 39.01, like approximately 40. So name is portability and the data type is float 64. So here in the code I'm going to show you that like 0 means water is not suitable for drinking, 1 means water is suitable for drinking, whereas like we got 60% here. That means that 60% of the data having non-suitable samples, 1 water is suitable for drinking and 40% of the data having suitable samples. So by this we gonna clearly see that only 40% of the water is suitable for drinking and the 60% is not suitable for the humans to drink the water as it is. So coming to the target visualization, visualizing the target variable. So here we're gonna visualize the target variable. So as we can see the code sns.set, we have taken as the figure and the figure size. The figure is 10 and the figure size is gonna be 5, and we have count the plot of the portability. So sns.count plot x is equals to portability and data is equals to data set, and the title of the data set data is target distribution. So how much data is distributed? So target target is distributed. So as we can see that 0 sample distribution is higher than 1 sample distribution. So as we can see the count 0 to 2000 here, and the 1, as we can see like 0 sample distribution is higher than the 1 sample distribution. So as we can see in the text is 0.5 and 1 and the target distribution. So try and test split. Coming to the try and test split, splitting the dataset into try and test split by using scalar model selection. Try and size has 90% and test size has 10%. So yeah, we gonna split the data and test the data. So by using the sklearn model selection, splitting the dataset into try and test. So from sklearn dot model selection import, uh, we're gonna import the try and test and split. So we take the variable x try and x test and y as the try and y test. So x and y are the variables we take over here, and the try and test split x y test size, we're gonna get the test size as 0.1 and the random state is 30 and the st ratify is equals to y, we're gonna take as y, sorry. So this is how we got to try and test and split the data. And coming to the data optimization, so here we're going to optimize the data. We can scale the data by using the standard scalar method available in the data processing. The main aim of scaling the data is to follow the normal distribution or Gaussian distribution. So standardize the data. This technique is mainly used for to make the data to normal data. So as we can see in the code, so we're gonna use this technique to read the data easily for to normal distribution. So from here, as we can see, the sklearn dot processing import standard scalar. Scaling is equals to standard scalar, and we have implemented the x10 and x test in the data optimization. So standard in the standardizing the data. So x10 we can see that scaling dot fit transform x10. X test is we given as scaling dot fit transform x test. So here we're going to implement the x10 and x test over here. So ML model analysis. So in the ML model analysis, building the logistic regression and predicting the results. This model has given 61% of accuracy for me. So let us see. As we here we're gonna take the confusion matrix. So from a scalar matrix, we have to dot matrix. We import a confusion matrix. So we have to just like take the confusion matrix and we have to test it by the y test, and from matrix we have to classify the report as we given the classification report, and classification report is y test and pred test. We have to take the pred test too. So as we can see the matrix over here, confusion matrix, it's 200 and 0 and 128 and 0. So here we're gonna see the precision, recall, f1 score and support. So for 0 and 1, you can see the differences. For 0, we got the precision 61, recall 1, and F score is 0.76, and support we got 200. Uh, Taking 1 as a value, so we got 0 as precision, 0 as recall, 0 in the F score, and we got the support 128. So here we're gonna even get the accuracy, macro average, and the weighted average. As the accuracy, we're gonna see the 0.61 and 328, and macro average, and we did we cannot take the precision, recall, and the accuracy. We can get it. So we're gonna get the macro average of 0.30, 0.50, 0.38, and 328, following the precision, recall, f1 score and support. So and the weighted average is higher in precision than the macro average, and weighted average is 61 which is everything higher than the macro average. Weighted average is more, and the support gonna be the same, 328. And excuse me, random forest classifier. So here in the random forest classifier, we have has given a 66% of accuracy. So as we print the classification report, and we're gonna test it with the y test and pred test. Again we're going to print the confusion matrix and confusion matrix y test pred test, and in this we're going to see the precision, recall, f1 score and support. Here in this, for the 0, we're going to get the high values rather than the 1. As you can see over here, 66, 91, 76, 200 for 0, and for 64, 27, 38, 128 for 1. Again here the average, the accuracy gonna be the accuracy, micro average, and the weighted average. We're gonna get the support as same, 328, and we're gonna get the accuracy as 66 for f1 score, 57 for macro average, 61 for weighted average. Again there is no recall and precision for accuracy, and 0.65 and 65 for precision for both macro and weighted, and recall is 59 for macro and 66 for weighted average. So finally we're gonna get the confusion matrix as 181, 19, and 94, 34 accordingly. So coming to the conclusion, logistic regression with 61%, KNN with 59% accuracy, SVM with 60%, Gaussian kernel SVM with 61%, Navi Bayes 61%, Decision trees 58%, and random forest with 66% accuracy. As we have seen the results, we need more data to take more effective decisions. So let us check the code once, and I want to show it. Just a second. So this is the code which I've got it. So first we wanna simply import the pandas and then numpy, and then import warnings, and we're gonna import seaborn as SNS, and import pyplot as PLT. So first thing, as we said in the discussed in the PPT, we're gonna get the loading the water quality data. So in the first step, we're gonna take the water quality. Here we got the, we have to read the file, and we have set it as dataset.shape. So we're gonna get is 3 to 7, 6 and 10. And coming to the next tab, we have taken the head as dataset.head function. So Here we're gonna see, as we discussed in the PPT, we got the values over here. And step one, checking the null values. So here we're gonna check the null values. So and then we're gonna write all the pH hardness solids, and we got the values of it. And finally we want to print total values. Our data set is nulls dot sum. So as I said in the PPT, we got the total null values of 1434 in the code. So our data set has missing values. We need to remove all these null values or replace with the median or the mean. So filling null value methods, replacing with mean or median, filling with zero for all the null values. So filling null values with zero, data set is can we can use the data set dot fill ending zero, and the data set had zero had sorry. So as you can see above that, the data set doesn't need any conversions because every feature contains the numerical values. So we can directly feed our data to be the machine learning model. So as we does not have any conversions because our feature contains numerical values, we are directly going to the feed the values in the machine learning model data. So here we're going to take the statistical analysis. We have to do the statistical analysis and data set with the data set dot describe. So as you can see, the mean, median, and the count and the standard and the percentages we have taken from minimum to max. So these are the different values we got for each of the column. So the count gonna be 3276.000, and it's for 25% it's gonna be 5.28, and 50% it's gonna increase to 6, and 75% 7, and if you go to the maximum it's gonna be 14. So dependingly, if you see in the hardness too, it's gonna be increased. The minimum, the standard gonna be very less, and the minimum gonna be something increased, and 25% is 176, 196 to 16. It's gonna go on increase as we attain the 25, 50, 75 maximum values. So and now we have to correlate the target variable. So dataset dot corr. So and the next thing we have to do is portability value dot cons, and the len data set is multiplied into 100. Here we're gonna get, as we discussed, the 0 we got the 60%, and 1 is 39%, which is approximately 40. So as I said, that 0 means water is not suitable for drinking, that is 60%, and 1 means water is suitable for drinking, that is 40%. And here's the data visualization for the target variable. So above we can see 0 sample distribution is higher than the 1 sample distribution. So this is the thing. So we implement the plt title, plt hist, plt dot show here, and see, as you can see, the pH rate is, hardness is, and the solids, chloramines, sulfate, conductivity, organic carbon, trihalomethanes, turbidity, potability. So almost all features following normal distribution. So this is very important for linear model, otherwise we need to normalize the data using the scaling methods. So by using the scaling methods we're going to do it. So as you can see, though, we have taken the X data set of the pH, hardness, solids and everything, and Y data set as portability. So X is equals to X dot fill n is 0, splitting the data set into train and test. So we have to split the data for training and testing. So we have, as I said in the PPT, we're gonna take it from sklearn model selection, and we're gonna import train and test in this split. So after that we have to standardize the data. this technique is used to make the data to normal distribution. So this is very important to make the data to normal distribution. So from this we want to input the standard scalar. So we're going to take xtrine scaling fit transform and xtest scaling fit transform. So here we're going to do the xtrine and test. So machine learning algorithms analysis. So the first thing is the logistic regression. So training the model and predicting. So we're going to train the model and predict the values. So as I said in the ppt is everything. So here are the values for it. Here we take in the scalar matrices to impute accuracy score and confusion matrix. And we're gonna import with the classification report and the confusion matrix with y test and prep test, and classification report by y test and prep test. So in the confusion matrix we got for this as 200 0 128 0, and I have discussed the accuracy macro average and weighted average in that. And the same thing in the knn from sklearn.neighbors. So we have okay, neighbor classifier, and neighbor is equals to, we have the take in the value as 10. So pretest clf dot predict x test. So accuracy score gonna be, you wanna take y test and pretest. We got a value as 0.5945121. So next we have to print the classification report and print the confusion matrix, and then we're gonna get the values as 176.24 and 109.19. So svm linear, the same thing we're gonna do for the test. Take the classification report as y test and red test. We got the values as 200 0 128 0 and the Gaussian kernel svn. So from sklearn svm import svc. So we're gonna test and train it. We got the values 192 and 124.4 and navy base classifier. So from sklearn navy base import Gaussian nb. So after training and testing it, and the confusion matrix we're gonna get as 182.18 and 107.21. And Dacian tree classifier, coming to Dacian tree classifier, we got the values as 137.63 and 74.54. And coming to the random forest classifier, well, we're gonna take from the sklearn.en symbol. We're gonna import random forest classifier. So random forest classifier, random state gonna be 70 and an estimator is gonna be 300. So we're gonna try and test it, and accuracy score, we're gonna get the accuracy score and the macro average weighted average, and we got the values of the precision recall and score support, and we got the values of the confusion matrix for random forest classifier is 181 19 in 1 and 94 and 34. And coming to the ADA boost classifier, we're gonna take the ADA boost classifier, n estimate is gonna be 100. We're gonna try and test it, and the values we got is 169 31 and 98 30. So comparing the accuracy results, so random classifier is given the best performance among all the algorithms which we applied above. So as we can see, we have done the uh, eight classifiers. So in that, the random forest classifier is given the best performance among, we have taken the eight algorithms. In that we got the random forest classifier as the highest value in all of that. So optimizing the model using randomized search CV. I choose the random forest classifier because it has given high accuracy when compared to all the models. So as it has given the highest accuracy, I have taken the random forest classifier. So here we're gonna take the more sklearn model selection import randomized search CV. So number of trees in the random forest. So I'm gonna take the n estimators is gonna be 50, 100, 150, 200, and 300. Number of features to consider for the split. Max feature is gonna be auto and SQRT. So maximum number of depth in a tree. So the depth value is gonna be 5, 10, 20, and 30, and the minimum split sample split gonna be 2, 5, 7, 10, and the minimum sample leaf. So here leaf gonna be 1, 2, 3, 4. So the bootstrap gonna be true or false. Creating the dictionary for random grid. So random grid and estimators, max features, max depth, minimum sample split, minimum sample leaf, bootstraps. So randomized search CV, estimator gonna be random forest classifier, param distribution is called random grid, n iter is equals to 100, cv is equals to 3, verbose is equals to 2, random state gonna be 42, and n jobs is minus 1. Applying the random grid model, fitting 3 folds for each of 100 candidates, totaling 300 fits. So random state is equals to 42 and the verbose gonna be 2. Clearly, so clearly we're gonna see the above is having less code than the default model. For this database, random forest default model working the best. So this is the code. So as we said, so in the conclusion, we got the logistic regression 61, K9 59, accuracy SVM 60, Gaussian kernel 61, and as we can see the random forest with 66% of accuracy. So that is the highest among all the algorithms which I have chosen. So that's it. Thank you everyone. Thank you so much.